All right, so how can knowing the reference angle be useful? Well, this is why. So it says here, find the exact values of the 6 trigonometric functions for 210 degrees, okay? So not knowing what the trig values of 210, I don't know what they are. However, I do know the values of its reference angle, okay? So the first thing you're gonna do is identify the quadrant that it's in. So if I have 210 degrees, it lies in quadrant 3. Agree? Because it's in quadrant 3, I know that in order to find the reference angle, I don't know why my picture showed up so early. There we go. In order to find the reference angle, you saw nothing, okay? That's going to be 210 minus 180, right? So to find the reference angle, we're going to do 210 minus 180, which equals 30 degrees. Agree? Could I find the sine, cosine, and tangent of 30 degrees? I surely could. The only thing that I'd be mindful of, because it's in quadrant 3, that when I find the sine, cosine, and tangent, everything is negative except tangent and cotangent. And that's because what quadrant are we in? 3, okay? If you can't remember what the sine, cosine, and tangent, a good reference is to always draw your triangle out. If I have 30 degrees, 30 is across from 1. Across from 60 is my square root of 3. And my hypotenuse is 2. That's what it's going to be, the same thing for every 30, 60, 90, right? All right, so if I need to find sine, cosine, and tangent, could I easily use this as my reference to find my sine, cosine, and tangent? Yes. So the sine of 30 degrees equals what? It's, well, sine of 30 is 1/2. But the sine of 210 is what, Justice? It's going to be negative 1/2. Does that make sense? Okay, what about cosine of 30? Cosine of 30 is adjacent over hypotenuse, right? Cosine is adjacent over hypotenuse, so that's going to be square root of 3 over 2. So therefore, what is the cosine of 210? Negative square root of 3 over 2. The tan of 30? The tan of 30 is? Well, there we go, because 1 over the square root of 3 becomes square root of 3 over 3. And therefore, the tan of 210 is also positive square root of 3 over 3. And the reason why it's positive is because what? In quadrant 3, the only thing that is positive is tan and cotangent. Okay, now that I have these, can I easily find its reciprocals? They're reciprocals. So the cosecant of 210 equals what? What's the reciprocal of negative 1/2? Negative 2. Perfect. The secant of 210? 2. So 2 over square root of 3 becomes what? 2 square. There. 2, say it again. 2 square root of 3 over 2. There we go. So we get negative 2 square root of 3 over 3. And then the cotangent of 210 degrees equals? Remember, I was 1 over square root of 3. Now I'm just going to be square root of 3. And so here are my 6 trig for 210. And I easily did that using my 30, 60, 90. Okay. Do we see the 30, 60, 90 come together? And using those values? Okay. If you draw it on here, it also helps you remember that it's going to be a negative square root of 3 It's going to be a -1. And then that's why, and radius is always positive. How we feel? Okay, do we see the build on from yesterday today? How they go together? Okay, so yesterday was about all of our acute angles, 45, 30, and 60. Well, 30, 45, 60. I probably should set that in order. Today is about the non-acute, so everything bigger. All right, so when you're doing it, so finding the trig functions, first you're going to make sure that it's between 0 and 360. So whether you're subtracting or adding, to make sure that it's between 0 and 360 is up to you. Next, you're going to find your reference angle. And then step 3, you find the trig values of our reference angles. So using our right triangle rules, right? Our special case right triangles, the 45, 45, 90, and our 30, 60, 90. Do these 3 steps sound doable based on what we just did? Yes? Okay, cool. All right, after that, make sure that your signs are correct based on the quadrant that you're in, okay? So making sure that your signs are correct means that you remember the fact that all students take calculus. All signs are positive here, only sine and cosecant, only tan and cotangent, and only cosine and secant, okay? So remembering where things are positive will guarantee that you have your correct signs. Cool. All right. Stop showing the pictures. All right, so here it's asking us for a specific trig value, right? It says the cosine of -240. Well, in order to find the cosine, step 1, we need to make sure that it's between 0 and 360. Is our theta between 0 and 360? It is? No. So in this case, I'm going to need to find the what? So we're at theta equals -240. What am I going to need to find for it? I'm going to add 360 to find its coterminal. Does that make sense? So we're going to find its coterminal. So to find my coterminal, I'm going to have -240 plus 360. So -240 plus 360 gives me what? Gives me 120. Okay, so now I know that I'm actually going to be looking for the cosine of 120. Okay, in order to find the cosine of 120, I'm going to find its reference angle, but I got to determine what quadrant does 120 lie in? Quadrant 2. In order to find the reference angle in quadrant 2, what do I do? Minus it from 180. Good job. So we have 180 minus 120 equals 60 degrees. So I'm looking for a cosine of 60, which means I'm doing a 30, 60, 90 again, right? So in my brain, or if I have to write it, I used to write it out all the time. Like every time I take a quiz or a test, the first thing I wrote on it was my special triangles, my 30, 60, 90, my 45, 45, 90. To me, that was just the fastest way to make sure I get it out and I have it as a reference. I can't make you, but I strongly encourage you. So we have 30, 60, 1, square root of 3, and 2. Are those going to ever change? No. So what is the cosine of 60? It's going to be 1/2. Your adjacent over your hypotenuse. Okay, so the cosine of 60 is 1/2. What is the cosine of 120? It's going to be -1/2. And why is it -1/2? It's in quadrant 2. So therefore, this is the cosine of -240. Oh my gosh, look at that. Yes, we did it. So now we know the cosine of -240. We're geniuses. Yeah. But you see how all these things are piling on, right? Coterminals, then reference, and then our specials. Yeah. I'm so excited about making our unit circle tomorrow. Trig is my favorite thing to teach, by the way. Just thought I would share that with y'all. It's like a puzzle of angles.
Nobody gets happy.
Y'all are haters. Okay. All right, your turn. How'd you know? It always be your turn at some point, right? All right, you're up. Tan of 675. What is the first thing you need to do? Good job, because you need to find a coterminal. I believe in you. Fun fact, my pre-calc teacher's name was also Mrs. Jones. Just thought I'd share that with y'all. I got on her nerves. I guess this is punishment. So.
I think that's. I did say that.
It's been a long morning already. Got it. Once you understand it, it's really not hard. You gotta admit it. It's not terrible. How are you angry? I know y'all hear it. You don't hear that computer growling? No, I hear this. Oh. I thought the battery would have died by now, but it's still going. America, you hear that? No. Okay, just make sure I'm not crazy. Are you ready? All right, what's my coterminal?
Oh.
Anyone? No, my coterminal. Say it again. 315. Because as my coterminal, what is my reference? 45. Good? Okay. So we got our coterminal, we got our reference, right? And so because of this, we're going to use our 45. Does it really matter where I put the 45? No. So we got 1 square root of 2. And we're looking for the tan of 45. What is the tan of 45 degrees? 1, right? So the tan of 45 degrees is 1. However, where does our coterminal in 675 lie? In quadrant 4. So what does that mean for the tan of those two? It's going to be negative. So the tan of 315 equals -1, which means that so is the tan of 675. How we do? We're geniuses? I knew it. Okay. Feel good? Coterminal reference, use your special, use the right sign. Coterminal reference, use your special, use the right sign. Okay. All right.
Oh.
This is the fun part. This is where it all comes together, guys. Like all of it. This is where it all comes together. Okay. So you have to find the cosine of 120, the sine of 60, and the tan of 30 in order to answer. Once you have those values, it's just substitution.
Oh, wait. Wasn't this on the test? I think this is on the test. Or the review one. So if it's like, so then after we find like the sine of 16,
We just substituted
we square it?
Mhm.
Oh, okay.
Yeah. That's it. It's just now combining. So first up, we're gonna do the cosine of 120. In order to find the cosine of 120, we're going to use its reference angle. What is its reference angle?
You're like.
We're a cosine of 120. What's the reference angle? We're in quadrant 2. So 180 minus 120 is 60. So we're going to look at the cosine of 60. So you remember how? So do you remember how I said sometimes it's helpful to write out that chart that I put up at the end of the notes yesterday? So you don't have to keep drawing it, but you can also just think about your triangle. So keeping your triangle in mind. Okay. Keep your triangle in mind. 30, 60. You have 1, square root of 3, and 2. So what is the cosine of 60? Cosine, adjacent over hypotenuse. 1/2. Where do you see square root 2 over 2? You wrote that. You wrote your chart. I didn't write your chart. So the cosine of 60 is 1/2. What would be the cosine of 120 then? Negative 1/2. Good job, Johnny. So we know that this is going to be negative 1/2. So we found cosine. Now we're going to find sine of 60. What is the sine of 60?
1 over.
Square root of 3 over 2?
I swear to God.
You wrote your 2 instead of a 3. That has nothing to do with me. Is square root of 3 over 2. Opposite over hypotenuse. Okay, are we good? I don't know. I didn't write the notes, but somehow it's my fault. Interesting. Tan of 30. What is every tan of 30?
Well, hold on, let me look real quick. Square root of 3 over 3?
Yes.
Okay.
So the tan of 30 is square root of 3 over 3. Because opposite over adjacent, which is 1 over the square root of 3, which becomes square root of 3 over 3. Do I have all of my values I need to plug in? Yes, we do. It's not a sure. Yes. So cosine of 120 becomes what? Negative 1/2. Plus 2 times sine of 60. What is sine of 60? Squared minus, what's the tan of 30? Square root of 3 over 3. Squared. So we found our values, we plugged them in, and now it's just numerical. So we have negative 1 over 2 plus 2 times 3 over 4 minus 3 over 9. At this point, I can't open a calculator. We've already discussed this.
Why do the square root go away?
When you square a root, it sets it free. Okay. And remember our exponent rules, what you do to the numerator, you do to the denominator.
Okay.
So it's the square root of 3 squared, 2 squared, square root of 3 squared, 3 squared. And then we keep doing the math. I'm okay with doing math out loud. You guys are not a fan of it. So I'm left with negative 1 plus 3/2. That's going to give me 2 over 2.
No,
Minus 3 over 9. Which equals 9 over, not 9. Yeah, 9 over 9 minus 3 over 9, which equals 6 over 9, which equals 2 over 3. I was getting there. I was doing it without a calculator. You had a calculator, a stolen one at that.
She talking to you more than that.
All right, how do you feel? No, what happened? But was it terrible? What part was terrible? The red, the purple, the black, or the green? Okay. All right. Yes. Are we good with being able to evaluate? We're doable with evaluation? Okay, so again, first thing foremost is you find your cosine, your trig values. After you find the trig values, you plug them in. After you plug them in, you must simplify. Got it? All right. Next, it says here, evaluate the cosine of 780 by first expressing the function in terms of an angle between 0 and 360. We've already been doing this. What do I do first? I'm going to subtract. So I got to find my coterminal. In order to find my coterminal, I have 780 minus 360. What does that give me?
4.
So what does that tell me I need to do again? Subtract again. And now I'm down to 60. Okay. So this lets me know that this is going to end up in quadrant 1. And in quadrant 1, all things are positive. So therefore, the cosine of 780 equals the cosine of 60. And what is the cosine of 60? 1/2. Look at y'all.
Why is it so late in the notes? Speak up, Justice. People can't hear.
I don't know. I guess it's to make sure that you're comfortable with it. Because I'm supposed to just kind of go through it without extra stuff. Without the steps, without the things. All right, your turn. Last but not least, cotangent of negative 405. How well y'all are doing trig. Bravo. I'm not jinxing you. I was trying to give y'all a compliment. Mm-hmm. Cotangent. Remember, cotangent is adjacent over opposite. Just reminding you. That's it. That's all I have to say. Let me know when y'all are ready. Are you ready? All right, up first. What is my coterminal? 315. Okay, since that's my coterminal, what is my reference? Equals 45 degrees, but we're in what quadrant? Quadrant 4. So in quadrant 4, is cotangent going to be positive or negative? Negative. All right. So what is the cotangent of 45? Well, cotangent of 45 is 1. So therefore, the cotangent of negative 405 is going to be negative 1. How we do? We can do it. We feel confident? Yes. All right.
Here we go.
Let's go backwards. What if I give you the answer? Can you tell me where it came from? I believe in you. We got to find the theta that makes this true. Okay, so because our cosine is negative, what quadrants are we in? And 2. Because cosine is negative, that means we only can have angles in quadrant 2 and in quadrant 3. Does that make sense? Because these are going to have positive cosines. And do we want a positive cosine? No, we do not. Okay, so thinking about our 30, 60, 90 and our 45, 45, 90, which triangle gives us square root of 2 over 2? 45. So we know that our reference angle has to be what? 45 degrees. Does that make sense? So our reference angle has to be 45 degrees. So we're looking for an angle here. That's 45 degrees. And we're looking for an angle here. That's 45 degrees. So what are my thetas? My first theta could be what? 180 plus 45. And my other theta is going to be 180 minus 45. So what are my two angles?
35 and 225.
Mhm. Good job, Johnny.
I don't know. We were all pretty sick.
I just heard Johnny's voice. I can't read mine. So if you said it in your head, good job, Justice.
No.
Okay. All right. So we got to the point. We understood that because we have square root of 2 over 2, our reference angle had to be 45. Agree? And we understood why we're in quadrant 2 and 3 is because that's when cosine is negative. So our two thetas that would make this a true statement would be 225 and 135. How do we feel about going backwards? It's not that bad, right? Oh, you say not good?
Yeah.
Oh, my bad. Why is it not good? Okay, so when we talk about square root of 2 over 2, is a 30, 60, 90 triangle going to produce square root of 2 over 2? No, because it's 1, 2, and square root of 3. So that means that the only triangle that will produce that is our 45, 45, 90, right? So therefore, my reference angle has to be 45. And because I don't remember who said it earlier, Johnny said we have to be in quadrant 2 and quadrant 3 because that's the only areas where cosine is negative. So I'm looking for an angle that is 45 degrees above 180 and 45 degrees below 180, which is why we added 45 and why we subtracted 45. So then our two answers are 225 and 135. That means that the cosine of 225 is negative square root of 2 over 2, and the cosine of 135 is negative square root of 2 over 2. I'm listening.
So like to find, okay, so like if we took 225 and we swapped it like regular.
It's going to come out to be negative square root of 2 over 2.
Is that supposed to be the right?
Yeah, so our reference angle, so we're going backwards. So instead of having the angle and finding the reference angle, we have the reference angle and we have to find the angle.
So 25 less 80.
Yes, and that'll take me back to 45. This is solved. We're done. We're done. This problem is solved. Oh, on which part?
Okay, so if we have
Yeah, so if this problem said, what is the cosine of 225? Right? You would say, okay, it's between 0 and 360. Check, no coterminal needed. Next, you would find your reference angle. Then you would,
Which is
yes,
45.
yes. And then we would
Which is
find
in-
angle, the reference angle doesn't have a quadrant. Your reference angle is just saying how far are you from your nearest x-axis.
Oh, which is the acute, right?
Yes.
Yeah.
Okay. Are we good now?
Yeah.
All right.
Wait, so what would you do if you didn't know which triangles?